Hello everyone. So today we're going to go over 29 options for the tree command. This is Linux as simple as possible. So let's jump right in. Okay, so you can see here at the title, Linux command equals tree. And what does this exactly do? This lists the contents of a folder in a tree-like format. Okay, so what does that actually mean for those of you who don't know yet? So if we do a recursive ls, you can see here that we have the contents of the current working directory plus all the subfolders and files. But it's kind of messy and it doesn't look it's not presented very cleanly. So what we need to do is we need a method to see the contents better in a more presentable format. So the tree command does that. So let's give you an example of that and we'll compare the two. Now see, this is the same current working directory and subfolders and files, but it's, as you can see, it's presented a lot more cleanly and a way that's easier to understand. The blue text means it's a folder. The white text means it's a file. So that's the basic tree command. Now, if we want to search an external folder, so you can see here that we are in the optemp tree directory, but what if we just wanted to search optemp, but we don't want to change directory? We would simply type tree and then the directory that we would like to run the tree command across. So optemp. So you can see again, I type tree optemp. This tells me I'm searching in the optemp folder. There's a folder called find, and it has all these files and folders underneath. There's a folder called grep, and it has all these files and folders underneath. And then here's the tree folder, our current working directory, and these are all the files and folders underneath. So that's how you search files and folders with the tree command externally to your current working directory. So let's jump into the next piece. So we already saw how to tree an external folder. Oh, and by the way, as usual, this spreadsheet will be available to you on my GitHub for you to download. Use it, as a reference file for yourself at your work, or download it and follow along. Okay, so next we are going to look at the tac a command. Tac a means all, and the example is tree space tac a. And what does tac a do? It lists hidden files and folders as well as your standard files and folders. So let's jump in and see what that looks like. Here's the regular tree command. Notice that immediately underneath the optemp tree folder are these two files. Now, what if we if we type tree tac a? Bam! All of a sudden, this hidden file shows up. And why is it hidden? Because it starts with a dot. So, again, to see hidden files and folders, use the tree tac a option. Okay, we'll clear this. Now what's next? Tac d for directories only. So tree tac d, what does this do? It lists only directories in a tree format. So standard tree command, tree tac d, lists only the folders. Easy enough, right? Okay, next, tac f for full path, tree tac f. What does this do? It displays the full path prefix for all results up to the current directory. Let's see what that looks like. So normal tree tac f. So see what it's telling us here is this subfolder called sample. It is under the level 4 folder, it is under the level 3 folder, and it is under the level 2 folder up to the current working directory. This is the empty file, and it's the same thing. It's under level 4, it's under level 3, and it's under level 2 up to the current working directory. So that's what that is. It's a tree tac f is an easy way to see the full file path up to the current working directory for each result. Okay, let's clear this. Tac L for level, uppercase L specifically, since Linux is very case sensitive. So tree tac L2, what does that do? Well, that displays the subfolders in a tree format, but only 2 levels deep. So let's take a look at that. So to really get a good understanding of this, we will go tree tac L1. So 1 level down. What does 1 level down mean? It means current working directory. So inside of only our current working directory are these 2 files, these 2 folders, and these 2 files. So I'm going to remove that tree.html because that's going to give us a error later in the presentation. So again, tree tac L1, this only shows your current working directory. But if we type tree tac L2, now this shows current working directory plus the contents of the first of the subfolders within the current working directory. So that's 2 levels down. Level 1 being current working directory, level 2 being 1 level down from the current working directory. And of course you can go down to level 3 and so on and so forth. Okay, what's next? Tac P for pattern, uppercase P. In our example, we have tree tac uppercase P, star.txt, and tac P empty. So what is that example command doing? Well, it's displaying all the files in a tree format that end in .txt or begin with the word empty. So tac P means match the pattern, but a thing to notice here with this command is that we can match multiple patterns in one command. So you see in this command we're matching anything that ends in .txt and anything that starts with the word empty. Now let's jump in and take a look at that. Tree tac uppercase P for pattern, star.txt, and for those of you that don't know, this star right here, that's just a wildcard. That's saying any character or number of characters, but it has to end in .txt. So if we do that, let's just run that. You can see it's only bringing us the files that end in .txt, right? Now, we can run the same command again, but we can add another tac P for pattern, and we can type empty star. So give me anything that ends, or excuse me, that starts with the word empty, but has any character following. Now we have all the .txt's, and we also have files that start with the word empty. And we can probably go on to 3 or 4 searches in one line, but we're just showing you 2 just as an example. Let's see what's next. Okay, so this next one is going to be ignore pattern. So just like with uppercase P, we wanted to search a pattern. In this case, we're telling it to ignore this pattern. So tree tac I star.txt and tac I empty, that would say, hey, don't show me files that end in .txt or start with empty. So you can see here in the explanation column, this displays all files in a tree format that do not end in .txt or begin with empty. So let's jump in and see that. So we'll run the last command where we searched for those types of results, and we'll just replace the tac P with the tac I. Now you see it will give us anything that does not end in .txt or start with empty. Now you might see this empty and you might go, oh, wait a minute, why is this empty file showing? It starts with the word empty, yes, but it is uppercase empty, and we told Linux don't show us anything with lowercase empty. So we can get around that by ignoring the case, and we'll show you that. It's next, I believe. Okay, ignore tac ignore case. Ignores upper and lower case in a given pattern. So tree tac uppercase, all uppercase empty, tac ignore case. What does that do? Displays all files in a tree format that begin with the word empty, regardless if it's uppercase or lowercase. And of course, tac P means match the following pattern. Let's jump in and take a look at that. So we'll do tac P empty, right? So that will bring us this empty result, right? Now if we do the same command, but we type tac ignore tac case. Now it's ignoring the uppercase requirement, and it's giving us files that start with lowercase empty as well. Pretty simple. So let's move on to the next. Tac prune. Don't return empty folders. Interesting. Tree tac prune. Displays all files and folders, but prunes the empty folders and won't display them. Let's take a look at that. So here's a regular tree command. You can see we have an empty folder here called sample. There's nothing inside of it. So if we go tree tac prune, all of a sudden that sample folder goes away because we told Linux, hey, prune empty folders. We don't want to see those. Easy enough. Let's jump on to the next one. Okay, tac no report. Omit file and folder count. Tree tac no report. Displays all files and folders in a tree format, but will not report the number of files and folders at the bottom by default. Tac no report means omit reporting the count of files and folders at the bottom. Let's take a look at that. If we run a regular tree command, you can see here it counts up the number of directories and the number of files that it found at the bottom. But if we type no report, it will omit that count of files and folders at the bottom. You see how it's blank down here. And why does it do that? Well, it's probably for something like running the tree command in a bash script where you might not want the superfluous information. That's just a guess. I haven't used it at work myself, but that's an educated guess. If you know of a particular use case for that, let me know in the comments. Okay, next. Tac P, permissions. Tree tac P, what does it do? Displays all files and folders and includes permissions and type. This is kind of like running the ls tac l command. So let's jump in and take a look. Tree tac P. Okay, now we can see empty file 1, for example, It's a file because it doesn't have a D here. And the owner has read and write access. The group owner has read access, and everybody else has read access. And then so on and so forth for all the subfolders and files below. So just a quick way to run the tree command and take a look at permissions at the same time. Okay, now we'll go next. TAC U, display user. Tree TAC U displays the files and folders in a tree format along with what user owns the file or folder. Let's take a look at that tree. Here's a regular tree command results, tree TAC U. Okay, so we see here, file owned by Handshot First. It says the owner is Handshot First. Sample file owned by the root user. Sample.txt file is owned by the student user. Now, if we go to the next option I'm going to show you guys, this is the same thing but with group, TAC G display group. So what does it do? It just displays the files and folders again in a tree format along with what group owns the file or folder. So we can run the same command, but we'll replace the TAC U with the TAC G. Now it'll show us the group that owns file owned by Handshot First. You can see the group is Smugglers. It's owned by the Smugglers group. Now what if we want to see both? Well, we just go tree TAC U G or GU, either one. Now we can see both. The result that comes first is the user owner, and the result that comes second is the group owner. Same with sample.txt down here. The user is shown first, the user owner, and then the group owner is shown second. Pretty simple. Okay, TAC S for size, tree TAC S. What does it do? It displays the files and folders in a tree format along with the size in bytes of the file or folder. So, just to refresh our memory again, regular tree command, tree TAC S. Okay, we see the size here. This file is 53 bytes. This folder is 4096 bytes. Now keep in mind that 4096 is the standard default folder size. So even if there's nothing in it, as with this sample folder, Linux is still going to call it 4096. Now we see also sample.txt down here is 139 and sample file is 149. So that's just a quick way to look at the size. Okay, so next we have human readable tree TAC H. Displays the files and folders in a tree format along with their sizes in kilobytes, megabytes, and gigabytes. I looked in the man pages. This doesn't actually show them in kilobytes, megabytes, and gigabytes. It shows them in actual kilobytes and megabytes according to the man page. So we'll try to avoid getting hung up on that. So tree TAC H, display files and folder sizes in a more human readable way. So it just adds them up basically, and it sums the bytes into kilobytes and so on. So tree TAC H. Now you can see the 4096 for each folder has been changed to 4 kilobytes. You can see, let's see, there's not another good example in here. Basically know that it took those 4096 bytes and now displays them as 4 kilobytes. Okay, next. TAC DU, disk usage. This is a good one. Tree TAC DU TAC H. What is this doing? Well, it lists the contents of the folders and subfolders along with the file directory sizes in a human readable format. So TAC DU, so that shows the size on disk or disk usage. And of course, TAC H means human readable. So let's take a look at that. Tree, TAC D. Well, first let's do this. We'll look at human readable again. I want you to pay particular attention to how this folder says 4 kilobytes. Level 2 folder says 4 kilobytes. Now let's go tree, TAC DU, TAC H. Now it shows the level 2 folder as 16 kilobytes. Why is that? Well, that's because this 4 kilobyte folder plus this 8 kilobyte folder equals 12, plus the 4 kilobytes of the level 2 folder brings us to a total of 16 kilobytes. So again, 4, 8 is 12, plus the 4 default for this folder equals 16. And this 44-byte file and this 49-byte file, they're so small that Linux isn't even throwing that into the calculation. So that's a nifty one if you want to see, how big your folders are getting with the tree command. Now, the next option we're going to go over is TAC uppercase D, date of last modification time. So this is kind of a tricky one, so pay attention. So tree TAC D displays the files and folders in a tree format along with the date of the last modification time. So what does modification time mean? That means the contents of a file or folder changed, right? The contents, not the metadata, not that nobody changed the file to say it's a different owner now, or change other pieces of metadata on the folder. So let's take a look at it, and hopefully this will be more clear. Okay, so last modification time. Interesting. If we take a look at this, we'll see February 15th was the last time that file owned by Handshot First was modified. Let's VI that. Well, first let's do this. We'll stat it. What does stat say? Modification time, the 15th of February, right? Okay. Sudo vi Okay, so let's go inserting more text. Now remember, we're modifying the file here because we're changing the contents. Now let's run that stat command again. Now you can see that it was modified on the 31st. Okay, we did some other things to the file as well. That's why all the dates changed. But modified means the contents of the file or folder change. So if we run tree TAC D again, you can see here, now it shows file owned by Handshot First was modified today at 0958. Pretty nifty, huh? Okay, what's next? TAC F, append indicator, tree TAC F, displays the files and folders in a tree format along with an indicator if the result is a file or a folder. So what does it do? Basically, if it's a directory or folder, it throws a / at the end, indicating its status. So if we run the regular tree command, notice how the folders are in blue. But if we run tree TAC F, notice how the folders are in blue, but now they have / after them. This is good if you don't see any color. So if we run it without color, you'll see that, well, let's run it like this. Okay, so see how the folders are now in white, just like the files? Sometimes when you log into a Linux box, the folders will be default displayed in white, just like the files. So if you want to differentiate those two, you can run tree tac f, and it will show. Well, let's do this. It'll see how now they're all in white still, but now it shows the directories with a /. We'll get to the end switch a little bit later too. Okay, T, sort by modification time. Tree tac T. What does this do? It displays the files and folders in a tree format and sorts the output by last modification time instead of alphabetically. The tree command will sort results alphabetically by default, but if we run tree tac T, it'll sort them by the last modification time. So modification time again means the last time the contents of the file or folder changed. So let's jump back in, tree again, and then tree tac, what was that? I just lost my train of thought, tree tac T. Okay, look at this. So regular tree command, file owned by handshot first, is up here. But if we do tree tac T, sort by modification time, file owned by handshot first is down here, right? Let's take a look at that. So you can see here, this is the file we just modified, and then the modification time for folders and files get older the further back we go, or the further up the list. Okay, let's jump to the next. Tac C, change, tree tac C. What does this do? Displays the files or folders in a tree format and sorts the output by the last modification or change time. So, tac C, sort by modification or change time. Modification time meaning the time when the contents of the file or folder changed, and change means a metadata change. Oh, there's a typo there. That's going to give me an OCD flare-up. Changed means a metadata change, like owner group, timestamp, etc. So, tree tac C. Let's jump in and take a look at that. Tree tac C. So you can see again, it puts file owned by handshot first up front because that's the one that we just modified, right? And this is sorting by modification or change time. But let's take a look at this. Tree tac C, D, oh, put a 0 there. Okay, modification time, most recent on file owned by handshot first. How about that sample file though? This one right here, March 15th. Let's stat that, have a look. So it was modified on the 15th, it was changed on the 15th. Okay, interesting. It was accessed on the 30th, but it was modified and changed on the 15th. So what if we do something to this sample file? Oh, that's not what I wanted to see. Oh, killing me. Okay, we can see here sample is owned by root, the user root, and the group root. What if we wanted to change the metadata? So we could go sudo change owner, we'll go student sample file. Okay, easy enough. Now we can see that the sample file changed the user owner. Okay, so if we run tree tac, we'll just run tree tac C, we can see now that the sample file is sorted and placed in front of the file owned by handshot first. And that is because it was modified, or excuse me, it was changed the latest, right? So let's stat that file. See how it says changed on the 31st. Now, it still says modified on the 15th, because remember, we did not change the content of the file. We just changed the user. So that was just done on the 31st, just now. So again, tac C, the sample file was the last one that was changed. So that is placed first with the tac C for changed command. Okay, enough on that one. Let's move on. Tac U, unsorted tree tac U, displays the files or folders in a tree format and does not sort the output. It simply lists them. It simply lists the results as they exist. So again, by default, tree will sort everything alphabetically. This is a way to tell tree not to sort anything. So standard tree command results, tree tac U, not sorted. It's just all thrown in there. Why you would want to do that? I can't think of a use case off the top of my head again. If you know of one, go ahead and throw it in the comments. But it's kind of a nifty little way to sort things as they exist. Okay, tac R, reverse order, tree tac R. So displays the files and folders in a tree format, but reverses the display order. So the reverse of alphabetical, basically. Let's jump in. Tree command, again, standard tree command. Notice the files that start with F are up here. The files that start with S are down here. Now, but if we go tree tac R, it flips them. The files that start with S are at the top, and the files that start with F are at the bottom. So just reversing it. Tree tac R. Okay, what's next? Dirsfirst, tac dirsfirst, tree tac dirsfirst. Displays the files and folders in a tree format, but displays the folders and their contents first. Let's jump in. Regular tree command, tree tac dirsfirst. Now, you see how it grabs the subfolders first and displays their results before it displays the files in the current working directory. Now, the next thing we're going to look at is tac files first, which is the opposite. So, displays the files and folders in a tree format, but displays the files before the folders in each directory. Let's jump in. Tree, regular tree command, tree tac files first. Now you see it takes all of the files in the current working directory and displays them first. Then it displays the subfolders and their contents. So it's kind of a quick way to look at the files in your current working directory first, and then, just for some extra information, take a look at what's in the subfolders as well. Tac sort by size. Tac sort equals size. What does that do? It displays the files and folders in a tree format, but sorts them according to their size, largest to smallest. Let's take a look at that. Regular tree command, tree tac sort equals size. Okay, interesting. Let's go. Say we want to take a look at how big they are as well. So we'll throw the tac H command on there. So, largest first. The largest file in the current working directory is 149 bytes. So it displays that first, and then it goes all the way down to 0, which is this empty.txt file. So largest at the top, smallest at the bottom. And then we'll move on from that. Tac I, do not indent, displays the files and folders in a tree format, but will not indent the subfolders and subfiles. So let's jump in. Tree, regular tree command, tree, tac I. Gets rid of the indentation. Why would you want to do this? Probably bash scripting again. Maybe if you wanted to run xargs across the results of the tree command and you needed all the white space and the excess characters gotten rid of. That's my guess. If you know of a better use case, let me know in the comments. Or let us know in the comments, since other people will be reading those and hopefully get some benefit from it as well. Tac N, here's the option I was using earlier. Tree tac N will not color the folders different from files if it is set by default to do so. So tac N means no default colors. Let's jump in. Again, regular tree command. You can see the folders are blue. However, run tree tac N for no colors, and the folders are now white, just like the files. Okay, next. These are good ones. Tac O, output results to a file. Tree tac O, optemp tree, tree.txt, outputs the results of the tree command to a file under optemp tree. So tac O means send the output to a file. So let's jump in and take a look at that. Tree tac O, optemp tree, tree.txt. Okay, so if you're wondering what I just did there, is basically typing sudo bang bang in Linux nomenclature. An exclamation point is known as a bang. So double bang, bang bang. So sudo bang bang just runs the last command that you typed, except with elevated privileges. So that's the only difference. Okay, so we have this file now called tree.txt that I just created. So if we want to see what's inside that, we can run the cat command across it. What this looks like, just the tree results. Well, that's because it is. We just stuck it in a file. So if we open it in VI, here's the contents of that file. You see it has some excess characters. But this is basically the results of the tree command in a file. So we'll get out of this. Go ahead and remove that because we don't need it. It was kind of wonky to read anyway, but let's see what's next. Maybe there's something more helpful. Tac O, again, except this time we're using tac capital H. What is that? Tac tree, tac capital H period tac O outputs the results of the tree command to an HTML file. Tac H means HTML output. So there's other options like JSON and XML. I tried the XML version. It didn't really look, it wasn't fantastic. I tried the JSON version as well. The JSON was a little bit disappointing. It didn't format it in a standard way that I'm seeing JSON. It wasn't as human readable, but the HTML is probably the best version I've found. So that's why I'm showing you guys the HTML version. So let's jump in and see what that looks like. Tree, tac H, period, tac O, opt, temp, tree.html. Okay, now we can see we have this file called tree.html. Okay, so that should be the contents or the results of the tree command. So let's open that up really quick and see what that looks like. Okay, now we see this is the folder structure of the current working directory in a web page. Well, that's pretty neat. It's pretty cool to see. But the coolest part is I can go, let me see this folder. So I can, So I can click on it and it'll give me the contents of this file in a web page. I can go back. There's nothing, that's an empty file, so there's nothing in there. I can see the contents of this folder in a web page, or excuse me, this file in a web page, and then see the contents of this file in a web page. So it takes your directory structure and it puts it into an HTML page where you can click around and see the contents of the files. Probably not all the files. These are just text files. So they're pretty easy to see. So that's pretty cool. I like that one a lot. So let's see what is next. Okay, tac help and tac version. Not super exciting, but can definitely be helpful. Tree tac. Oh. So sometimes for some commands the tac help is not much help, but with the tree command you can see it gives us a lot of different options for running the tree command. So if you ever are at the bash prompt or in some shell and you can't remember the option really quick that you're looking for, you can just type tree tac help and it will bring up the help file for you. Also, tree tac version will show you the version of the tree command that you're using. This can be important because if you are using the tree command and it's not working quite the way that you're used to, you might want to check the version, and maybe you have an older version, maybe you have a newer version than what you're used to. So checking the version number is just one of the steps of troubleshooting when you're having difficulty utilizing a command. So that is that, and I believe we are at the end. Awesome. So thanks for hanging out with me. That was 29 different options for the tree command. Go to my GitHub, link in the description below. Grab this spreadsheet for you to use at your work or wherever you like to use Linux. And we'll see you next time. Thanks for joining me.